Hello students, our last topic is design of adder and logic circuitry. In here, we have the circuit contain three stages. First is JK flip-flop stages and other is your 7 input stages. The 7 AND gate input stages contain adder and logic circuitry and last is your accumulator stages. So here total 16 stages, that means one bit required one stage. That means one bit contain corresponding with the one stage. Here for designing a adder and logic circuit for one stage you required two AND gates, two OR gates and one JK flip-flops. Other is you have to take load signal from the slide. That means if your load signal will be 1, then and then your accumulator will perform its original operations. Here one is clock signal also required for designing a here is that the signal is AND, add, load, INPR, COM, SHR, SHR. These signals are same as we discussed in previous slides. These signals are coming from the adder and logic circuitry. Same way for other inputs are accumulated. That means the feedback, the result of the accumulator is goes to the input side of the 7 gates, 7 AND gates. Another input is your data registers. So suppose you have to get for suppose you want to perform an AND operation, then AND operation required three inputs. Your AND inputs, then accumulator and DR. Here I is represent the value from 0 to 15. That means total 16 says then that that require total 16 bit operation. Suppose you want to perform your operation for second bit of accumulator, then I equal to 2. For I equal to 2 and then accumulate second bit, same way data register second bit performing AND operation, and this AND operation value will be loaded into the OR gates, and according to the II, that means your load inputs, you get some result, and this will be your control the circuit of JK flip flop. So here for performing the JK flip flop operation, you have to require two signals that come from LD and other is II. That means your load signals. II we can say that it is a input label that coming from control and logic circuitry. Same way here, other is a in input side you required 7 AND gates, 1 OR gates and one full adder circuitry. Suppose you wanna, we can take the example step by step. This first is AND operation, second is add operation. For add operation you have to require in first add signal and second signal is coming from the full adder. The full adder contains the three inputs. First is your CI, second is your accumulator and third is your data register. According to the 3-bit operation you will get the sum, and the sum will be goes into the AND operation, and this AND will be loaded into your OR gate. Same way for load operation. So for load operation you have to take only data registers and load signals that come from the previous slides. INPR, that means you have to perform input IO ports operation. You required a input registers pin as well as input register for I bit that will coming from the accumulator. Same way SHR and SHL require two that not required a same bit. Suppose you have to perform a shift right operation, then if you required accumulator value is for 1 bit, then here is you have to load its second bit, then you will get your actual output of the accumulator. Same way for shift left operation, if you are performing accumulator I value is 2, that means AC 2. Then 2 minus 1, that means accumulator's 1th bit. So you have to load accumulator 1th bit is here, and SHL will coming from the control and logic circuitry, and end operation between these two you will get a input for second bit, that means for AC of 2, that means I of 2. Here one NOT gate is also required for complement operation. Here total the circuitry is divided into 3 parts. First is your full adder and 7 AND gates and 1 OR gates. This is your adder and control logic circuitry. Here load signal is given to the, we can load signal is coming from the logic gates. That means we can say that it is a control gates circuitry. And last is your accumulator that performing the different operation. This size of the accumulator is 16 bit. So we can say that we can perform adder and logic circuitry for 16 stages. Thank you.